Hello, everyone. Thank you so much for joining us today for our first Autodesk workshop. Just a reminder, there will be 3 workshops. The second workshop will be in October 27, which is 2 weeks from now. Hope to see you guys again. And pretty soon we'll be passing out as well a form for sign-in sheets, so we can actually send you guys emails as a reminder as well for those days that are coming up. Yeah. So my name is Francis Simpson. Thank you so much for coming with us. I'm a part of SME. This is a collaboration between 5 groups. With ASME-CoT, MAES, Robotics, IEEE, and SME. Today, our guest speaker who will teach us about Autodesk Fusion 360 will be Thom. Thom, if you don't mind.
Well, hi there. I'm Thom Tremblay with Team D3. Years ago, I used to work with Autodesk in the education group, very much in the role that Jared Advanced Coder is in right now, as well as being more of a technical specialist as well. So just glad to be here tonight. We'll just keep it fairly simple. Just do a kind of a high overview. I'll get into a little deeper in modeling for this session, and then kind of cue some things up for the next 2. Hopefully the session, the 27th, and I think it's November 11th or something like that, we'll do a little bit of hands-on. So please bring your computers to that and have Fusion 360. If you want to just watch, that's great too. Anything else, or should we just go?
I believe we can just go ahead. Just to let you know also that this is being recorded, so anybody who would like to have access to this recording, just let us know on the chat and we'll be happily send it to you.
And I'll try and keep an eye out for any questions or anything else, and otherwise you can just unmute and ask a question too. But for tonight, as I mentioned, we'll keep it fairly high level. So I've been using this stuff for a long time. In fact, I started doing 3D and CAD in 1988. I don't know if there's anyone in that room that was alive in 1988, but I was doing 3D back then, and it was very painful. Also worked through a lot of different applications, including Inventor and SolidWorks. And I was on one of the internal project teams at Autodesk when Fusion 360 was first conceived. And Fusion 360 was brought about from the idea of creating a tool that would allow the non-professional CAD user to be able to leverage the capabilities of 3D parametric design. And what would that do for the professional? What doors could that open if you approached it from a different perspective? So very, very interesting development process, and Fusion 360 has just continued to develop and develop and develop, and to become really kind of unique in the whole atmosphere of 3D CAD. So tonight we'll talk a little bit about collaborating. That's a very, very important element of Fusion 360 that's radically different than most other systems. In fact, I can't think of another system that works as smoothly as Fusion 360 especially for group efforts. And we'll talk more about that. Do some parametric modeling. I'll show you a number of different techniques. I won't necessarily show you the best way of doing it because I have no idea what you're going to be making. So you'll have to discover what the best approach is. But I want to expose you to a number of different tools and some different concepts along the way. We'll get into some assembly tools, because assemblies, if you've used SolidWorks or Inventor or Creo, are radically different in Fusion 360. And if I've received 20 phone calls over the years from someone who's experienced in those other tools being thoroughly angry about Fusion 360, only to have them end the call very angry that their existing tools didn't do it the way Fusion does, I've received 100 of them. We'll talk a little bit about 3D printing, and then we'll give a little preview talking about some of the manufacturing capabilities, which will be the focus for the 3rd session, I believe. And then we'll talk also about some freeform modeling. Hopefully we'll get to that, especially with the broad variety of people there. And we'll also talk about some of the additional workflows that are available, not just the ones we'll be able to cover in future workshops, but ones you should be aware of, especially if there's electrical engineering folks in the room and robotics folks. You definitely need to know about some of the other things Fusion can do. As you all should know, hopefully, if you don't, go ahead and be able to hit the QR code or go to autodesk.com/education to download the software for yourself, not just Fusion 360. If you haven't been to this site yet, go in, register, create an account with your credentials as students, and access any of the tools that are up there. There's some phenomenal tools for simulation. CFD, there's a great CFD tool up there, a lot of other advanced design tools. Go explore what's up there. All the software that's on the education community is actually the top level of the professional version. It's not some student version that half the buttons don't really work or any of that. They're all full-blown professional grade softwares. Check them out. In fact, there are some capabilities, including in Fusion 360, that are available, or in particular in Fusion 360, that are available to education accounts that aren't yet available to commercial accounts. So check out the education community. So Fusion 360 has evolved to be an incredibly broad tool. Uh, for industrial designers, for people who are just doing conceptual work, research and development. My last real job was doing R&D on centrifugal compressors years ago. And I don't know how many times I spent hours and hours and hours coming up with a model that would never, ever see the light of day. It was either for measurement or metrology. It was a fixture to make some test part, or it was just a concept that I wanted to share with other people. And it turned out the idea wasn't what it needed to be. But with traditional parametric systems, you can put an enormous amount of work into and build all sorts of part files and assembly files and everything else, just have them go nowhere. But then on the engineering side, Fusion 360 has phenomenal capabilities with parametric modeling, with assembly modeling, with distributed design, and with simulation and collaboration. Collaboration is a core element of Fusion 360, all the way out to the shop floor. So if there's anybody there that's focused in manufacturing or manufacturing processes, the CAM tools inside of Fusion 360 are absolutely fantastic. And you have access to all of their functionality at no additional cost as education customers. But in order to get there, Fusion 360 also needs to be very flexible when it comes to modeling. So of course, parametric modeling has been the rule of the day for a couple decades now, or actually almost, well, 3 decades. Parametric modeling makes perfect sense in the engineering workspace. We build things to tolerances, we build things based on dimensions. So parametrics make sense. However, Fusion offers a lot of other things. You have parametric sheet metal capabilities, surface capabilities if you need them, though there are alternatives to what surface modeling is traditionally used for in Fusion 360. Also direct modeling. So if you have a component that, let's say you're going to be making a part for your fixture, or if you're on one of the competition teams and you can download a 3D CAD model of a component that's on your vehicle or in your competitive element, but you need to make a modification to it, you can do that with direct editing. By the way, Fusion 360 will import virtually any CAD data from any system. No worries, it works fantastically. But you can also do freeform modeling, which is where we get into incredibly complex shapes in a very, very different workflow. And hopefully we'll have time to touch on that tonight because it's an amazing process. And but also, if you are working with existing things, rather than having to spend hours and hours and hours modeling stuff that already exists, that you only need to add things to, you can use meshes directly in the file and also use meshes to get started with your designs in Fusion 360. I mentioned collaboration a couple of times. Collaboration is just core to Fusion 360, and that, of course, comes from its use of the cloud for all its data. So it doesn't matter if you're on Mac or PC, Fusion 360 works on both. As education account holders, you can also run Fusion 360 through a browser if you're working with a Chromebook or having to work remotely and you don't want to install software on a system. All of your data will be accessible. You can also share that data with others. I would have to double check, and you probably want to check with Jared if you have access to what are called folder level roles. Folder level roles allow you to, by folder, establish whether or not someone has editor capabilities, reader capabilities. For those of you in competition teams or working on capstone projects, you can even make outside stakeholders or mentors viewers. So through a web browser or through a mobile app, they can mark up your data and add comments and be able to review the work you've been doing without even having to have Fusion 360. All of that is built in, all of it's available at all times. We'll take a little look at that. The other thing, as far as the data goes, is it has inherent data management. Every time you save a file in Fusion 360, it creates a new version. So if you're exploring an idea and at some point there's a fork in the road where you make a choice to pursue the concept this direction, you can always go back to an earlier version and either create a parallel design or take it and make it the current design. If your idea doesn't pan out, you aren't losing anything by exploring. And that's phenomenal, especially in your situation. So all of that's just part of Fusion 360. Another thing that's part of Fusion 360 is the concept of distributed designs. So when we get to modeling, I'll talk about the fact that Fusion 360, I'll talk more about the fact that Fusion 360 can incorporate the entire design. All of the components, assemblies, sub-assemblies can be built in one file. But if you need to collaborate with others, or you're working on a project, let's just, since I know there's some robotics people in the room, let's say you've got your overall robot assembly. Someone's going to be working on the structural elements. Someone's going to be working on the electronics. Someone's going to be working on the drive elements. What you can do is use a more traditional workflow, something like an Inventor or SolidWorks would use, where you're linking data in. But with Fusion 360, the first person that starts modifying a component is reserving it. So other people can continue to work in the assembly while this person is modifying that part and this person's modifying that part. And when they save, everyone else that's looking at the assembly or maybe a sub-assembly that's using those components will be alerted that a new version is available. This doesn't require a vault. This doesn't require VPN. It's just built in and it's just available to you. In fact, in Fusion 360 in the data interface, you'll be given notices all over the place that other people are using the data that you're working with. And you'll notice that some of the icons, might be a little hard to see with the projector, have little white dots on them. That means someone is actively editing a component and making changes to it. So you can anticipate, someone's, Mary's working on that part, before I go attempting to change it, which I won't be able to because I'll only be able to open it as read only. I need to either communicate with Mary or wait till she's finished with her work, and then I can start editing it. So it makes it very easy and very dynamic to work in that area. And like I said, not only when they finish will you be notified, you can refresh your view and make sure your assembly is up to date. What the data that you're working on is up to date and reflecting the latest changes. So a phenomenal collaborative environment built in. Working in the Fusion team, especially with education, you can kind of think of the Fusion team as your file cabinet. Fusion team is up on the cloud. This is where all your data is stored. Then you can set up your projects in various, you can create projects within that team that you might think about as the drawers. And then, of course, anything that's inside of there, you have folders, you have individual files, all of that can be organized. And as I mentioned, most education accounts are set up that they can limit who has the ability to do what. So you could have someone in Powertrain be able to view the frames and work with them and import them and do that, but they can't actually save anything to that folder or save the components that are in there. They can digest them, but they can't modify them. So phenomenal opportunities that are just built in. Okay, actually, I'm going to pass on this. This is more for educators. Let's talk a little bit about the interface. For those of you who haven't had an opportunity to use Fusion 360 yet, one of the things that makes it very usable, or one of the areas that they put a lot of energy, was in the user interface. So you're not faced with 400 toolbars as soon as you open up. The toolbar is focused in work groups or workspaces. So as you transition from doing design work to maybe doing programming for CNC machining or needing to do simulation, you change the workspace, it changes the toolbar, it keeps things focused. One thing that's also different about the interface for Fusion 360 that usually gets people's attention and can be a little frustrating for people with more experience in something like an Inventor or SolidWorks, some of the older tools, is the fact that the browser isn't the single source for all of the data. Fusion 360 leverages item number 7, the timeline, to be able to record the history of the progress of the design. And there are some distinct advantages to that. And the way Fusion's data is structured creates some real opportunities for a lot freer exploration. One thing I would point out, though, is item number 2, your profile area or the profile and help area. One thing that you can use to kind of kickstart your learning or explore new areas in Fusion 360, under the help menu, you have the ability to get to tutorials. And there are a lot of great tutorials that are just built into Fusion 360. And the data sets for them are also just built into Fusion 360. But under the preferences, you can set how you want to work and do all of that. So I mentioned briefly the browser and timeline. The browser is still used to organize the structure of the design. So for example, if we take a look at all of these components and all the elements of this design are in a single file, the mini drone assembly. The mini drone assembly, you'll see next to it, has a few blocks stacked up. That means you could look at that as an assembly. The base and arm underneath there are single blocks. So they are components. Inside of every component will be origins, will be any bodies that make up the 3D data for those components, and any joints that are relevant or were created in the component. So that's true for all of those elements. But you'll notice that some of the components, like drone motor and prop, are also a stack of boxes. That means there are components under that. Okay, so what's different is the timeline. The timeline captures the history of the design process across all of those components. That can, of course, lead to kind of a long timeline, but if you activate an individual component when you go to make changes to it, that timeline will shorten to represent only the features that are part of that component. So it's kind of easier to see. Let's talk a little bit about navigation, then we'll get into Fusion. If I always recommend a wheel mouse for those of you who might have Macs with trackpads or MacBooks. You have the trackpad options, pinch for zoom, 2 fingers for pan, shift and 2 fingers for orbit. For a wheel mouse, it's very simple. Roll the wheel to zoom, click and hold the wheel to pan, and shift and click and hold the wheel to orbit. You also have the view cube in the upper right of the display, and down in the navigation panel, we have all of our zoom, pan, and so on if you have to work without a mouse. Okay, so let's take a look at some of the interface elements of Fusion 360 and a little bit of that collaborative element, though we won't really be able to get super deep into that tonight. So here's my Fusion 360. I have my data panel open on the left. My data panel is my passage into working in folders and working in projects. I can close or open it using the show or hide data panel icons in the upper left. For those of you who might work on your own team as well as collaborate with others, you can have multiple teams that you're connected to and switch between them. That will switch you between entirely different, if you will, filing cabinets. So whole different sets of data. I mentioned the workspaces previously. Here's how you switch to, say, the simulation workspace or the manufacturer workspace. For example, if I switch over to simulation, I can see that there is a simulation case here. I can see the stress results are still there. And I can pop right back to design. And you notice all the tools change in the toolbar. Any tool that's used to create a feature or a sketch is reflected in the timeline using the same icon. and I can see the history of the design. In fact, I can even play it back, showing me what the process that was used to create it was. Okay. And as I mentioned, if I activate an individual component, if you take a look at the timeline, I'll activate the base and you'll see that it narrows it down to just the features that were there. To make a modification to a feature, all you have to do is edit with a double click or a right click and edit, and it will take you right back to the dialog as it was when the feature was created and the view preview as it was created. So if you're not the person that created a feature, you can go right back to the experience that the user who did had and be able to work from that. Okay. Now, speaking of going back to some of the collaboration elements, if I take a look at this file, so this is phone stand amplifier layout sketch V7. So this is version 7. If I look over here in the data panel, I'll see it over here. And I can click on the current version and see a history. It will show me when files were created and by who, or edited and by who. In fact, I can go back and see all of the history. And this is where I can go back to earlier versions. I can also tell it to show me the details of this design on the web, and it will launch the web client. So this is a view that you can share with anyone that you give access to. They're able to go in and see if there's any external files. So I mentioned distributed design, where you might link components in so multiple users can be editing individual components at the same time. This would show you a list of any of those components in this design, or if this component were used in other designs, you can see what designs they're used in. You can also see that there are CAM toolpaths and simulations. And if we click on the thumbnail, we can go in and see what the design looks like. The design can be interrogated for its properties. It can be marked up when measured. So I can go in and measure an element, get its XYZ values. I can mark things up if I want and comment. Leave a comment, save that comment. And not only will that comment be now visible in the overview, if I return back to the file, if you're working with others, they'll be able to go in at any time and see those comments right in the design file. So if you're working with people remotely or just trying to keep track of why certain changes were made, this is a great built-in mechanism for that, and it's available at any time and accessible from the web client or directly in the tool. So something to check out, and something that's a little bit different than you're used to if you've been using other systems. So again, just wanted to give you kind of a 50,000 foot overview on that. There's a lot of great material out on the web on working in teams, especially in a collaborative way in Fusion 360, and be happy to help you locate some of that too in the future. But let's talk about some of the other capabilities here. So for example, if you've been using parametric modeling already, there's a lot of things in Fusion 360 that are going to be familiar. The hardest thing to me with any 3D system when you're first learning is just understanding how to control a sketch, how to build out a sketch. And with Fusion 360, if you already know how to do it, you already know how to work with Fusion. Now, there are some things that are that are a little different depending on the product you're used to using. One of the things I like to include is the fact that any constraint or any dimensional constraint can have its parameter named in the process of creating it. The same is true when you're creating features. You can include parameter names. For example, extruding this block up, I can say height equals 1.25. So instead of having the traditional D0, D1, D2, D3 that every system uses, you can build that intelligence in right away while you're building it. So it makes it easier to communicate with others and build that content in. Then, of course, you go back and you make the same types of modifications, placed features like holes, fillets, shells, etc., just like you would be used to in other systems. And the key is that if you have experience with systems, you're not going to be starting over with Fusion 360. I mentioned the parameters thing. To me, that's a very, very important thing that often gets overlooked and often gets underutilized, being able to capture that design intelligence in the process. And one other thing that, depending on the older system you're using, is Fusion, you don't have to fully constrain things to be able to start exploring an idea. Rough in a rectangle, extrude it a little ways, make a modification to it, and then come back if the idea is sound or you're communicating your idea with others. If they say, that's great, now let's make it fit on our object, then you can go back and add the parameters, add all that detail information after the fact. So the other thing is this top-down approach. So the idea of being able to do your design in a different way. For example, most of the red, actually all of the red elements you see on the screen and the silver elements were designed from one sketch, one single sketch. So being able to lay out a mechanism or lay out a system and be able to build all the individual components and have everything still responsive to that original sketch, very different, very difficult to do in other systems. But it can be done. You can also create a broad variety of different geometry, as we mentioned before, whether it's solid or surface or mesh or T-spline. Okay, and it's just a different approach. So let's take a little look at 3D modeling. And like I said, I won't necessarily be showing you what I would say is the best way to do something, but I'll show you a way to do something. So in fact, let me go ahead and leverage a little bit of layout centric approach. So creating a sketch is still just creating a sketch. However, I want to do something a little different here. I'm just going to rough in my size, and for this height, maybe I'll say, I want that to be 0.375. I'll use my tab key, and let me say depth. Learn to spell here. Depth equals, let's go with 3. Okay, so I had it pretty close in the first place. All right. Now let me rough in another rectangle here. That's going to be my relief for my sound port. This thing is a thing you can set a phone in and makes kind of an amplifier. And this is going to be my stop component. And let me rough in a shape here and just simply drag in the constraint relationship there. All right, so let's throw on a couple dimensions. Let's throw on height. Let's make that, all right. Let's see, what did I get that for? Ah, that's why. Excuse me for a moment. Let me make that the same as that. And let's establish this width here. And establish this dimension here. All right, so we've got this kind of roughed in. Maybe that's a little too large. Make a quick modification here, and then let's start just building components. Now, what I want to do with this is when I start building my shape, I want to make sure that I'm separating out these bodies. Instead of just having solid bodies, which we can do in Fusion 360, I want them to already understand that they are separate components so that I can do machining for individual ones or 3D prints of individual ones and detail drawings and simulations of the individual components and have it work properly. So what I can do is I want to create a new component. And even though the sketch is a child of the top level, I can still leverage it in my subcomponent. Now I'll build this out. I'll say width equals 3. All right. And that, of course, consumed my sketch, but I can just turn that back on. Grab my profile. Now, it might be a little tricky to grab that profile because any face of a model in Fusion 360 can be used to create a feature. So if I want to grab something that's obscured, let's say I've got 5 components and I want to grab a face that's in the back, all you have to do is get where you think the object is, click and hold, and then choose which option you want. So here I'm going to pick the profile. I'll again just make that symmetric, establish what that value is, and create my feature. So I've got most of my base feature done. Let's go ahead and add a couple sub features to it. So I'll pick a couple edges, and I can of course drag that fillet out. Now, if I've done this once, I've done this 1,000 times, so I want to point this out to you. So if you go ahead and drag out this radius, it's nice that you get that preview. But then if you go to grab some of these other edges, you'll notice you're not able to. That's because Fusion has transitioned from selection mode to preview mode, or to establishing what the radius is. So what you can do is in Windows, hold Control, or in Mac, hold Command, and it will temporarily put you back into selection mode, and you're able to go in and grab your radius. All right. So for now, I'm good with the model as it is. Now I want to create this stop part, and this will be a separate part. So I'm going to go ahead and reactivate my top level. There's another way to do this, but I'll just do it the simplest way. And I want to create another new component called stop. And you'll see it grays out my base component because while that's present and while I can refer to it and while I can build based on it, it's not my focus. So instead, I'll use extrude here since this is active. You'll also notice right now my timeline is empty again. Okay. Come on, whip back. I'll give up. All right, and I'll select my profile. Now I can't get this zoom to stop. All right, so we'll have to deal with that. So I can tell it to go ahead and build this out. And this will zoom in here while I'm trying to type. Having Zoom on or Teams on always creates new, interesting interface elements. I'll say width. As I start typing WI, it'll give me the width option. I'll press enter and click OK. So that's an option of taking advantage of parameters as they exist. See if I can get this thing to stop. Otherwise, let me pop over to here. Unreal. First time that thing has ever done that. All right, so now I've got my separate component. If I activate my base component, I can see it's got its features. And of course, my sketch is still present. One thing I can even do is I can right click and tell it to show the dimensions of my sketch. I'm going to have to figure out how to get rid of that thing. If I double click, I'll get a zoom all. All right, pardon me for a moment while I have an argument with OS X. Boy, this is just beyond embarrassing. All right, so I'll turn it off. It's a nice feature to have, especially when it's not misbehaving. But here, either here, I can change this dimension if I want to make this shallower, or under modify, I can come up and go to my parameters. Now, here's something to point out. Anytime you name a dimension or name a feature, so for example, depth and height were sketch dimensions that I named. Width was an extrusion feature that I named, but you'll notice it made them favorites and automatically put them at the top level. But all of the details, every sketch dimension, every taper, extrusion taper angle is all captured as you would expect. But the way Fusion approaches it is much more straightforward than a lot of other systems. So leverage that and take advantage of it. Of course, here I can go in and make this value 2. I should have showed you that live here. Here, let me go ahead and change it to something else, 3. And you'll see how that stop component is getting thicker and thinner. Let me click on the view cube and let's go back to 2. All right. All right, I'll activate this, turn off my sketch, go to my home view, and now I've got this. Now, if I want to change the physical materials of the components, perhaps the whole assembly, I can go into my physical materials. And this is something that's going to be very important if you get into doing simulations, is you can not only use the huge library of materials that are built in. So for example, here's our 1 or 2 options for aluminum, but you can also create your own materials based on any other material. Beyond being able to control what physical material something is, you can also get into appearance, which is a shortcut key of A. So you can open up a library, you can drag bronze polished out on there, maybe get into some painted finishes, like a metallic green for our stop, something subtle. All right. All right, let's finish a couple more modeling things because I want to point out some really unique capabilities in Fusion. So this is an area, we're going to do a couple things that will freak out older 3D systems. The first one is one that most people that don't have experience with the older 3D systems, it just goes right by because to them it makes perfect sense. I'm going to start my fillet tool. I'm going to select this back vertical edge, this other back vertical edge, and notice that it's easy to select right through. Then I'm going to select these front vertical edges. But those of you who've used Inventor and SolidWorks are going, wait, those are on separate components. How can this be? Fusion 360 doesn't care. But what's really powerful is that is not an assembly feature. So for example, in Inventor, in SolidWorks, you can add a fillet to components at the same time, but that fillet will be a child of the assembly. That is a post-assembly feature, not a feature that exists at the part level. But if I activate the base, notice that fillet is there. If I activate the stop, notice that fillet is there, even if I missed a spot. I must have accidentally deleted something. There, I accidentally deleted that feature. But you notice how I was able to change the timeline to drag it so it's okay. Now we'll get into another graphics thing. Thank you, Zoom, with highlighted faces. But I want to show you a capability that kind of ties the browser and the timeline together. And this is not a default thing, but I kind of wish it was, which is down here in the lower right corner, there's a little gear. I'm going to click on it. Then I wish I could zoom in, but I had to turn that off and click on component color swatch. And of course, it used very subtle colors, but the lighter purple is the top level assembly. The darker purple is the base component, and blue, usually the problem is this is these really gaudy neon colors. The blue is the stop, but notice it might be hard to see, and yeah, I can't zoom in now, that the fillet shows that it is a child of both the base and the stop at the top level. Some other things that you can do that are pretty powerful in Fusion 360. For example, I'm going to back up over that fillet and create a sketch on top of my stop. what I want to do is I want to create a sketch that is going to help me locate where some holes are going to go. Okay. I'm going to use my constraints. All of my constraints are up here in one place. I'm going to use my horizontal vertical constraint, which can discern pretty well if I want something to be a horizontal constraint. I'll hold shift to find the midpoint, or a vertical constraint. Then I'll use my D key to launch my dimensions, sketch dimensions, and grab this edge and say I want that to be 0.4 inches. All right, so now I have drawn a sketch, in this case at the top level of the design. Okay, I could have created it in the stop. In fact, I think I can grab it and drag it into the stop. So now that sketch is a child of the stop. See how it's kind of fluid in its structure? Now, if I had created features and other components based on that sketch or using that sketch, I would lose some of that fluidity, but Fusion doesn't care. You can use a sketch in one component to define features in as many components, many other components as you want, or as we've done here, create as many components from one sketch as you want. Fusion's far more flexible than any other system for that. So now I have my sketch. Now what I want to do is I want to create a hole. In fact, I want to create a hole on each endpoint of this. And I want that hole to be tapped. And I want it to go through everything. And I want it to be sized for a number 10 screw. Well, I really don't want to tap the stop component, the green component. I really just want tapped holes in the bronze component at the bottom. So here at the bottom of my dialog box, I have an objects to cut. And I can say, do not cut the stop component. Another option that I have here is to say that rather than a virtual thread, which I would get in Inventor and other systems, I can say I want a modeled thread, because Fusion 360 was made after 3D printers. And if you 3D print a hole with a virtual thread, you get a cylinder. Okay, really hard to put a screw into a cylinder. It takes a lot of force. Okay, here we have modeled threads that will print out correctly. All right, so let's go ahead and create that feature. And now I have my modeled threads in the bottom part, in the bottom component. But I can always turn that sketch back on. And another workflow that I have is to go ahead and create these holes. Let's say I want to put them here. This time I want a counterbore hole that's a clearance hole for an ANSI unified screw thread, and I want it for a number 10 socketed cap screw. Okay, and I want it to go all the way through. Another option that I have here it would obliterate all my threads, but if I just quickly turn off my base component before creating this, I get the same effect as I would if I were to expand the objects to cut. And I'll say, okay, create that, turn off my sketch, turn on my base, and now I have my holes ready to go. Now the question is what to put in there. I have my inspection tools, so I can always measure things. I can check for interferences. I can also do things like section analysis, where I can cut into my part to see that, yes, those are physical holes. So let me just do a little measurement just to assess what size bolt I need. Okay, it's 0.56 inches, so 5/8 worth of thread would work. All right, so now let's model up a socketed cap screw. Or better yet, let's not model up a socketed cap screw. Let's go instead to my insert panel and go to insert McMaster car component. All right. And I'll come in here. As you can see, McMaster car, if you're not familiar with them, have one or two things that they offer in their catalog. Now, not everything is 3D modeled, but the important stuff, the common stuff like fasteners are, including some relatively exotic fasteners. In this case, we'll keep it kind of simple. We'll say that we want screws and bolts. I'll say, so I can see what my options are for screws and bolts. Okay, a lot of options here. And again, not all of those are 3D modeled, but I'll say I want inch. I know what thread I need. So as I select more filters, what's available to me in 1024? Still a huge variety of fasteners. If I can say that I want the length for a socketed cap screw that's measured below the head, I'll say 5/8. Okay, so now my options are less. I can say what material I want, maybe stainless steel, and it's narrowing things down. So from here, I'll just select one. I can scroll down. I can see what the part numbers are. I can see how much they are by quantity. And I can see that, man, I'm paying too much at Lowe's for a socketed cap screw, but at least I don't have to keep them in stock. So I'm going to select one of these part numbers. And what I'm looking for is this magic little icon that says CAD. If I see that, I know I can download the file, either as a fully developed 3D step file or one with no threads. I'll just save some CPU cycles and say no threads and click download. All right, now I have the model of my fastener in here. Oh, it's getting cut off by my view, which I could turn off, but I'll show you how to do that in a moment. I can roughen its position, and I'll just say okay. Now, the first example of our assembly stuff is I will place a joint. Okay, I'll place it between the top of the threaded shaft and this hole here and flip this thing over. All right, now if I don't want to see this sectioned up anymore, whoops. Oh, I chose poorly. I picked the wrong thing. All right, so operator error still exists. I'm going to turn off my analysis by just simply hitting the eyeball next to analysis, and I can go ahead and grab the fastener. I'll just ignore the fact it's wrong. I can always go back in and put another one in. Copy and paste and do the same thing. And of course, you could do a pattern of those as well, and it would work just as easily. Now, this brings me to another step, which is the idea of joints, and we'll dig deeper into assemblies in a moment. But I just wanted to show you the basics of how they're created. Now, the fact is that that stop was modeled in the correct position. So what I can do is I can not just use a joint, I can use an as-built joint and say that I want to establish an as-built joint that's rigid between those components, and it will just simply lock them in place. I could also create what's called a rigid group, which is really useful if you import, say, step data of a whole assembly. You can just make the whole thing a rigid group, or make some of it a rigid group and apply joints to other things, or even as-built joints. But joints come at things from a different way of working than constraints that are used in Inventor and SolidWorks and such. I'll turn on my fillets here. Show you those are still there. Joints come at things using joint origins. In fact, let's just talk a little bit more about joints. Constraints are built from the idea of using physical geometry or virtual geometry, like construction planes or work planes or work axes, to create relationships between faces and edges. How joints work is it's the concept of a joint origin that the relationship is created between. And joint origins can be placed in far more locations and can be oriented based on an element of the assembly. So you can pick the centroid of a face, but then set the joint origin off to the side to drop things in on it. The other thing you can do with joints that you can't do with constraints is change their type after the fact. So if I have two objects that I'm going to stack together, let's say I want to center two boxes, using constraints, I place a mating constraint, and it's still got that flexibility, those degrees of freedom. Then I have to apply another alignment constraint to align it to this edge, and it can still move, and another alignment constraint to align this edge, just to center two boxes on each other. With joints, I could put a joint origin on the center of this face and a joint origin on the center of this face, and just apply now, stick those together. And I can make it a rigid joint, which removes all degrees of freedom. Or later on, I could come back and say, no, I actually wanted that to be a revolute joint, which would turn loose a rotational degree of freedom. I already mentioned the as-built joint. The as-built joint takes two components that were modeled in the correct location or imported in the correct location and allows you to just join them together. But you can still change the joint type. So you bring in a hub and a rotor. So the hub is going to be joined or locked in place to your upright, and your rotor needs to be able to spin. So you can still do an as-built joint, but then define the rotation of axis for that rotor and put that degree of freedom in after the fact. It's a super way of working. And let me just show you a quick example of building an assembly. Let me also check the time. All right, we still got about half an hour. I'm going to open up another design just to show you some examples of working in the context of an assembly. Something that I really haven't talked much about is the distinction in Fusion 360 between bodies and components. Bodies are blobs of geometry, whether they be meshes or solids or surfaces. Okay, they exist within a component. If I open up a new design and just start sketching and extruding things, I'm creating a body. If I create multiple blobs of geometry, I create more than one body. Bodies are great, but they do have some limitations. I mentioned before, I can't do individual drawings of bodies. I can't do individual analyses of bodies. I can't put moving joints between bodies. That's why we have these containers. But what happens if you get kind of exuberant and maybe model something up before creating the component? There's a few different approaches you can use. One is like this. So here's another example of our phone stand where we have all our sketches and extrusions. This was created in a different orientation, but you'll notice all of these bodies and sketches exist at the root of the overall thing that will eventually need to be an assembly. But right now, it's just a standalone component. And if I'm going to be inserting this into another design and machining just this individual component or detailing just this individual component, it's just fine. But the moment I decide I want it to be assembly, I probably should have made a component before I did anything else. So here's a little trick you can do. And I've had to do this myself countless times because I'll have something in my head that I'm trying to get onto the screen and I'll be in a big rush and I'll start sketching and I'll start extruding or revolving and adding all this stuff. And then I realize, oh, I should have made that a component. So here's one technique. What you can do is in the timeline, and once again, I wish I could zoom in on this. I'll roll my timeline to the beginning. So nothing has happened in this design yet. Didn't happen. Never. No witnesses, didn't happen. Fusion 360, as far as it's concerned, I did nothing. This is a brand new, fresh file that happens to have a few versions. So what I can do is say, I want a new component. And I want it to be, well, just stay with the same base. Okay, so now it has activated a component named base, which has no history at all. And I have my stand. So I'll come back to my stand and I'll roll my timeline back to the end again. Okay, so now all my stuff is back, but it's still not in the right place. In this case, and it doesn't always work, and again, like I said, once you start creating multiple components from things, from sketches, or multiple bodies even from sketches, you can start to limit your ability to do this. But in this case, if I grab sketch one, the very first thing that I created originally, but now it was created after that component, I can grab sketch one and drag it into that component. And now all of those features, I don't know if you notice the color change here, have become children of that component. Okay. Another technique, if I pop back over to this assembly, is that this body is just that. All it is a body. Now this happens to have been imported from a step file. So I don't have that ability to do that, but I can still right click on this and say create a component from the body. Okay, so now it's created a base component. I can apply an as-built joint between it and the root to lock it in place with a rigid joint. So it's a rigid as-built joint. Now let's start applying some joints. Okay. If I start my joint tool, let me take a look at this face. as I hover over this face, you can see all of the midpoints are triangles. I can connect my joint origin to the midpoint, even of arcs. The center points are little crosses, so I can grab the center point of an arc or a circle. I can grab any endpoint, which are just dots. In this case, the square is the centroid of the face. Well, centroid of the face is always a square, but in this case, it's a little close to that edge. But I can grab any of those faces to apply my joint origin to, or at least base my origin from. If I rotate around a little bit, what I want to do is find the middle of this cylindrical face, or the center of the middle of the height and the axis of this cylindrical face. As I move around, it's pretty easy to find these two, but if I try to grab this end, I might get lucky. Oh, but just as I do, it picks up this edge, okay? What I can do in Windows, hold Control, in Mac, hold Command, while you're over the face you want to pick a joint origin based on, and it isolates it. So no matter where I move, whoop, I let go of my key, it picks it up. Okay, so I pick up that end. Okay, that's really not what I want, but I just wanted to show you I can. I'll grab the middle of that. Now, I'll grab the center of this face using that same technique. Holding Command, I find that middle. All right, so it's located. By the way, always grab the component you want to relocate first. Now I can kind of pre-position this, maybe at -3 degrees. That's all well and good. And right now, it's a rigid joint. I could change its joint type to revolve, which would break loose 1 degree of freedom. I could make it a slider, which would add give me 1 translational degree of freedom. I can do it and change these either from the mini dialog or from the large dialog. From the motion tab, I can make it cylindrical, which is 1 rotational and 1 translational, and the translational is in line with the axis of rotation. A pin slot, the translation is normal to the axis of rotation. A planar gives me 2 translational freedoms and 1 rotational. And everybody's favorite, the ball joint, gives me 3 rotational degrees of freedom. Now, if I change this to revolute, it naturally picks up what were the z-axes of those joint origins as the axis of rotation. However, you can change that to be a different orientation if you want, or even create a custom one. Z is the one that more often than not makes the most sense. And you'll also discover that the type of geometry you pick, whether it be an edge or a face, will give you better results for what you need. Okay, so let me apply a few more of these. I'm going to go ahead and apply a joint here. And now what I really want to do is center this. If I were using constraints, I would have to figure out what the differences between the measurements were, use probably an insert constraint, and do the math to center this properly. With joints, I can say that I want my second joint origin to be between 2 faces, and I can pick this face. And remember how we can pick through by click and hold? I can pick that face. Now all I need to do is define my rotation point. I'll pick it here. It gives me my revolute, and I'll just say OK. Now we could get into a debate whether or not it should be revolute versus cylindrical in the real world. That's fine, we can do that. But for now, I'm just going to go ahead and lock these in. In fact, this one, I'll go ahead and change it to cylindrical. I'll drop this in, change the joint type. Actually, I'll just use the mini dialog here to make it a cylindrical joint. So it will slide. Okay, and let's apply another joint here. And we'll leave this cylindrical as well. And finally, let's just drop in our last joint, which everybody is anticipating based on the center of the spherical faces as being, again, everybody's favorite, the ball joint. All right, so now we have this. We have this assembly. If I grab any component and move it, it will be allowed to exercise through its degrees of freedom. Okay. When I let go of it, it will ask me if I want to capture that position as a feature of the assembly, or if I want to revert it back to its original position. Now we have the option of looking for any physical contact in the assembly to define limits of motion, or we can just grab the joint itself. In this case, I'll grab this Revolute joint, say that I want to establish a minimum and a maximum degree of freedom. So I'll say I'll allow it to slide out to, say, around 130 degrees. Say OK. And now I can move this until it stops. It'll even bump off of that. Or I could even go so far as to say I want to create a rest position and define what that would be, say maybe 30 degrees. Okay, so I'll grab my assembly, move it around, let go of it, and it snaps back. So think about an actuator with a range of motion that for the purposes of your assembly, you want to come back to a certain position. That's how you do it. It's very simple, very straightforward, and nothing much to it. All right, so we talked a little bit about parts. We talked a lot about parts, but that, of course, is what you spend most of your time doing, is developing 3D geometry. Let's talk, okay, we talked about the saints. Let me show you this real quick, because there's a couple different techniques you can use to generate 3D geometry for 3D printers specifically. One is to simply save a mesh file out as an STL3MF or OBJ. So let me pop back here and grab, let me grab this one, and I'll show you what that looks like. So if you grab your component, or even just grab your body under your component, you can say save as mesh, and you can pick your file type. You can set your quality refinement levels or go to a custom one and go into all your options for your normal deviation, surface deviation, all that. You can deselect. Here, let me expand my dialog using this little grip in the upper left. You can deselect send a 3D print utility, or if you have a 3D print, if you have a slicer installed on your system, for Mac, you just go find that application, or Windows, you can do the same thing. And you can just say, hey, drop this out as, say, a high quality 3MF file directly to my slicer. And here we go. My Prusa slicer will launch, and I can go through all of my setup process and drop this out as a 3D print. The other option we have is to start getting into our manufacturing workspace. And so here's kind of an overview of what workspaces are available to you. Render, animation, simulation, all great, very different views. Rendering is super easy in Fusion 360. It uses HDR environments to create all the lighting and the shadows, the highlights and the shadows. Animations are great for exploded views. You can create drawings of those exploded views. You can also save out video files of the animations. Simulation, there's tons of simulation. We'll cover that in a little bit. And then for the next two get-togethers we have, we'll talk about the manufacturer workspace, which I'll get into in a moment, but also we'll talk about generative design. Generative design is a completely different way of approaching the process of creating geometric solutions to problems. Because ultimately, if we think about the parts that we design, they are geometric solutions that can be produced to solve an engineering problem. There's an old adage that says no one needs a half-inch drill bit. No one needs a half-inch drill bit. What they need is a half-inch hole in something. So the drill bit was created to give them what they need. Generative design flips the script on how we approach designing components to put the manufacturing process, the materials we would use, our costs, and what this thing needs to be able to perform or withstand at the forefront, and gives us suggestions on geometric solutions. So we'll talk more about that in a few weeks. But in the meantime, let's talk a little bit about, let's pass on drawings for now. Just know that you can create 2D drawings. We have our manufacturing workspace, and it's the same workspace for subtractive, workflows, and additive. So let me just pop over to that real quick. In fact, let me see here. Do I already have this done in this? Let me go to the manufacturer workspace here. Yes, I already have one created. I should probably show you this in our unfinished one. But let me just show you how here I can activate my top milling. So the stock that I'll use is shown in yellow. Since I made some changes to my component, I'll need to update the tool paths. So this is how long it takes to regenerate your tool paths after making a change. Yep. It's warning me that one didn't need it. Okay, what did I do here? Huh, that's odd. Come on. Huh. Not sure why it did that. Parameter pockets, no pocket. Well, let me edit that quick. Okay. I'm not exactly sure why it's arguing with me, but I'm going to go ahead and just quickly recreate these. Oh, actually, I want that first. Yeah, there we go. Here, let's go just go through the process. Let me just show you how to create an additive in here. Let's go to manufacture. We'll deal with the other stuff. We'll deal with milling here in a few weeks. And so I've got my models. I'll create a setup, and with your setup, you choose whether or not you want milling, turning, or mill turn. Cutting, so if you have a plasma cutter, laser cutter, a water jet, just a simple routing table, we'll use that. And then we have additive, and we can even select a machine. So for example, I can grab a Prusa Mark 3S. I can say what body I want to use. So maybe I don't want to print all of it. You know what? Let's go ahead and print those two. And of course, we'll ignore the screws because we're not going to print the screws. Although if you want to, go ahead. We'll say OK. Pick out what material we want to use. We'll go with PLA in this case. And it will lay those components onto the bed for me. Now, if I wanted to reorient those, I could. In this case, it just kind of got it right. So that if you don't want to see the screws on the screen, you can just turn their visibility off. It doesn't really much matter. All right. Now let's take a look at the process. I'm going to edit my my process. I can make any changes I want to the shell, to the infill. Maybe I want 35% fill. The printed bed adhesion, you can pick between skirt, raft, and brim. Change their parameters as needed based on what you select. Any supports, the speed information you have, any travel information, set your quality levels, things like that for tessellation. I'll just say OK and have it go ahead and generate my additive toolpath. The additive toolpath will take just a little bit. One of the things I really like both for the subtractive and for the additive is the fact that it will allow me to simulate those toolpaths. Okay, its complaint here is that the raft or skirt toolpaths have to be limited because of how close those components are together. And of course, like I said, I can move them apart, or I can just ignore that, and I can use my simulate. Oops, I needed to select that to say simulate. There we go. And it will show me my layers. So I can just kind of click through here and see what it looks like, get all of my information, how long it's going to take to get to that point. I can also animate the process, changing the speed if I want, make it a little faster, have it go back to certain operations or certain levels. So you just have a lot of options, and that's true also with the subtractive processes. So it gives you a chance, especially with the subtractive, to see if your order of operations makes sense. It will also do things like collision detection. So if you put in what kind of equipment you have the ability to, for subtractive, be able to say, select what your fixture is and have it look out and be on the lookout for collisions with the fixture. Here in additive, I can see what the build envelope is for that printer. In fact, it even gives a great facsimile of what the printer bed looks like, and even the removable magnetic platter. So very nice, but that's what that process is. Very straightforward. Anything you create just stays resident in the design file. It's not creating a separate file, though you do export your G code. All right. Freeform workflow. We got a few minutes here. I'll just show you a real quick example. It's just a different approach. So I used to be on a squad at Autodesk that would try to come up with solutions for super complex geometry using parametrics, using surfaces, what have you. Freeform allows you to create that geometry without having to know in advance what it is, because the problem with parametrics is, for super complex shapes, is you have to know exactly what you want and then construct all the elements for lofting or sweeps, things like that. With Freeform, you can just start exploring shapes. In fact, you can, with the way bodies work in Fusion 360, I can create a complex shape, copy it off to the side, and then keep editing, and then copy it and iterate and iterate and iterate. It really enables industrial design workflows inside of the process. But the tools themselves are different. A lot of times people refer to them as surface modeling, but they behave different than surface modeling. In fact, let me show you a quick example here. I have a partially finished model. So T-splines can create geometry all their own. So if the body is closed when you finish it, it becomes a solid, which is great, because then you can add parametric features to it, or do tool paths from it, or subtract it from one other thing and make a mold, which is what that example was, a candy. Freeform models can be created from primitives. So I'll say that I want to create, I'll just show you how a little bit of that shape was created just by dragging out some basic elements. And then I can grab any of these elements and use edit form to make modifications. So I can taper this in. I can hold my Alt key in Windows or my Option key in Mac and add additional faces when I'm moving or scaling faces using the manipulator. So here, let's add some more faces in. Let's lift that up a little bit. And you can see just how quickly you're able to create really complex geometry. And plus, you can take advantage of things like symmetry, where I can say I want 5 planes of symmetry on this component. Okay, so any change that I make to one, I can make to others. So for example, if I want to, one thing you don't want to do with freeform models is add too much detail up front. Instead, get your basic shape and add detail later. So let's see here, I want this to be both sides. I'll just create a little crease there that will be replicated all the way around. And I can use edit form again and grab these edges and just give them a lift, maybe a little push to the side. Maybe I can use edit form and grab this face and double click and grab the adjacent faces and just simply twist the whole shape around. And then let's go ahead and fill that in. Whoops. No, that's over here. Where is it? Fill hole. There we are. Grab that. Tell it how we want to shape that. Say OK. Let's do the tool again, this time on the bottom. I want to keep the edge sharp and say OK. And when I'm done, I have a solid model. So you can see just how long it took to make that shape. The other thing you can do with edit form is you can use more traditional tools. For example, in this case, loft. So I can say from this profile to this profile, using this side and that top. And I can come in and vary the number of faces. So again, I don't want too much detail. I want to be able to add some detail to it. I can also come back then and add some symmetry to it so that if I want to, I can make modifications later. But let me show you what a hybrid workflow looks like. I've got a couple other features in this model. Oh, let me finish my form, pardon me. So since that was an open body, that essentially becomes a surface. So I've got a couple other surfaces in here and a solid model that's down here on the bottom. And I have a construction plane in back. Check my time real quick. I can tell it to create a boundary fill. So when I say that we can do hybrid modeling, I'm saying that I can take this plane, this surface, this surface, this surface, and this solid, and I can tell it to find various bodies that exist with those. Then select one of them and make it a 3D shape. I could have turned off those other bodies in the process of that, which would have cleaned it up immediately. But I don't mind right now. So now I've got this basic shape. I can come in here and add fillets. Let me just orbit around and grab that edge. Sometimes my view is just a little too clean. Let's make that maybe 2/10 of an inch, and let's put a setback corner on that. Okay. So I've got this. I can do things like splitting based on a silhouette. And pick the body, split it. Okay, and now you'll see a crease is formed around it. Not sure what that is. I'll have to take a closer look at that. Oh, I must have it folded inside out. What I should have done before I split that, though, is I should have shelled that whole thing. So let me go back and say shell. In this case, instead of a face, I'll just say shell the whole body. Let me see if I can get it to behave. In fact, I'll even make it metric. Let me try something else. Point, make it thicker. Oh, that's okay. I won't worry about it for right now because I want to be able to go back to that freeform model and do a little edit form on it. Just grab that one point, swell it out a little bit. Maybe grab that face, scale it a little bit, pinch it in a little, say okay, finish my form, and have my solid update with that additional little bit of detail. In fact, under inspect, I can turn on my zebra analysis and see what that does to the curvature. All right, so there's just a ton of things you can do with freeform. Some of the other additional workflows in Fusion 360, of course, we'll be looking at CAM a little later down the road in a couple sessions. Promise I'll have my act together better than that. I still have to go back and figure out what that was arguing. But with education, so there is something called the Advanced Manufacturing Extension, which for most people is an additional charge to get a hold of 5-axis milling, some advanced solutions like steep and shallow, which actually comes from a multi-$1,000 CAM package that Autodesk creates called Feature CAM, or that one might be from Power Mill. Pardon me. You have turning, mill turning, 2D cutting, additive manufacturing, all that's built in. Like I said, tutorials for that stuff are all built into the system. Some other things you have are electronics design. So like I said, I think there's some electrical engineers and robotics people there. Full-blown thing from the schematic and even being able to do spice simulations of the circuits, full annotation. All that annotation carries out to the mask on the PCB editor or the silk screen of the PCB editor. You can do manual traces. You can do automatic trace routing all built into Fusion 360. You have your component editor where you can add custom components, but there's also still huge component libraries built in, and all of that generates a 3D PCB right in Fusion 360, which which when you really get carried away, you can in Fusion realize that maybe that RJ45 connector is in the wrong place. So in Fusion, you can move that component, which immediately screws up your circuit board, right? No problem. If you go back to the PCB editor, it detects the fact that that connector was moved. It knows that its footprints and pass-throughs and everything else are in a different location, and it will update the circuit board. Not only that, you can then use your CAM capabilities if you have some double-sided or pre-masked PCB material to calculate out your routing and your cutting. So all of it's just in Fusion 360. Your simulation workflows, everything from basic static stress with linear materials through nonlinear materials, structural buckling, thermal, quasi-static event simulation, electronics cooling, and now there's even an injection mold simulation that's in preview. All of that's available in Fusion 360. And then finally, with just a little time left, what we'll be looking at next is generative design. Generative design is, as I mentioned before, just a completely different way of approaching the whole thing. Now, one thing I will warn you on is Autodesk has a habit of always showing cool 3D printed shapes like that. Where I think generative design is particularly powerful is the fact that it can give you geometric solutions to your engineering problems, including the manufacturing process, the materials, and the costs, for not just additive, but 5-axis, 3-axis, 2.5-axis, die casting. All of that's available. And so you can compare in a very thorough way what the best solution is for you. You know, what geometries check off all the boxes and can be produced at the most in what the most cost-effective way. So all of that is just built into Fusion 360. So it's there. We'll take a look at. Oh, and by the way, fluid flow for generative design. If you need to design valves, or if any of you are involved with, say, Formula SAE and you're designing your intake manifold, things like that, find out based on the volumes and based on the velocities what the best and smoothest flow channel is for your fluids, whether it be air or liquids. So really cool stuff, all built in. There's great learning resources built in, I've mentioned a couple times. Also, if you go to Autodesk.com certification, one, you can look into what certifications are available, and there's a broad array from user certification, which is fairly straightforward, all the way up to professional and expert level certifications, which allow you to not only need to know the software, but to have domain experience as well. But that type of certification can really separate you out from other people competing for the same jobs. So tremendous resources. Check it out, autodesk.com/certification. If you have any questions for me in the meantime, feel free to drop me an email, or you can scan the QR for my LinkedIn. You're welcome to ping me there if you like. But with that, oh, and you can also take a look if you want another view of teams and collaboration. I did a session with a colleague from Autodesk that is focused on kind of working in teams and working with multi-collaborative environment in Fusion 360. You're welcome to go up there. AU Virtual is online. It's free. There's tons of resources there as well. Yeah, I know I didn't leave you much time, but if there's any questions, I'd be happy to answer them. Otherwise, feel free to drop me a note, and we can get together on them next time.
Thank you, Thom. Anybody have any questions?
Do you have any resources for SPI simulation?
Do you have any resources for SPI simulations?
Yeah, there's the tutorials that are built around the electronics design package have information on that. That would be my recommended path, is to go check out those tutorials. Also, you can also check out the forums. There's a forum specifically for the electronics design for Fusion 360 as well. That's a great resource. It's not just monitored by the developers, which it is monitored by the developers at Autodesk, but it's also monitored by people who are using those tools in the real world every day. That's what their job is. So those end up being really phenomenal resources. I happen to be a member of a group called the Expert Elite. You have to be nominated for it. Autodesk has, I think, 500 worldwide right now in various different domains, you know, civil engineering, architecture, mechanical engineering, manufacturing. And those people end up answering the lion's share of the questions on the forum. So they really are a great resource. Anything else I can help you with?
Yes.
If you already know AutoCAD software, how much of the shortcuts or information transfers over to Fusion 360?
AutoCAD specifically, the L shortcut key, highlighting, selecting things from right to left is a crossing window, from left to right is an encompassing window. Everything else I recommend you just forget anyway, because yeah, I started using AutoCAD in 1986, so I'm allowed to say anything I want about it. It's a rule. Look it up. One of the big things, great frustrations of AutoCAD that I think is wonderful about Fusion 360 in particular is that in AutoCAD, for every tool you learn to create something, you have to learn another tool to change it. In Fusion, with the features, the sketches, you go right back to that original state. It's just a very different paradigm. It's just a very different approach. So there really wouldn't be a lot of advantage. Now, your experience with AutoCAD as far as creating drawings will be useful for you to understand how to lay out drawings in Fusion, but you're going to probably be very frustrated with the amount of time you've spent in the past creating working drawings in AutoCAD once you see how drawings are created in Fusion. It's really fast.
Thank you.
You're welcome.
If I'm certified in Autodesk Inventor, how much of a learning curve would Autodesk Fusion be?
The key is to not use Fusion like Inventor. You can. So I mentioned the distributed design model. So in Inventor, you have IAM files for assemblies, IPT files for parts. Anyone in the room that's using SolidWorks, this all applies for Inventor SolidWorks. You can link designs into external designs into a design in Fusion, edit them in place just like you would in Inventor or SolidWorks, or edit them in their own files. But try to let Fusion be Fusion. So explore things like I showed where features can run across multiple components. Explore features, you know, the assembly joints will probably take a little time. Now, Inventor has the advantage for a few people anywhere, because Inventor does have joints as well. Although the joints in Inventor don't work as well as the joints in Fusion. It's odd, but it's true. Well, that's my opinion anyway. But so assemblies are usually a place that trip people up. But again, you know, just learn how joints are used. There's some good tutorials on that, and I'd be happy to answer any questions, of course. But yeah, it's not a one-to-one, but you're not going to be going backward, that's for sure. So all the knowledge you've gained for, this is true of SolidWorks or Creo, in how to control a parametric sketch or how you want to approach using geometric constraints versus dimensional constraints, that's a wash. I mean, that will translate directly. It's all the stuff downstream that Fusion tries to take an easier approach than the older systems do.
Anybody else? Good. Thank you again, Thom.
You're very welcome. Thank you for the opportunity, and I look forward to seeing you here in a couple weeks.